The LED array has 10 LEDs ranging from red to violet, and it also has an additional white LED. This allows investigations into how we perceive color, the relationship between frequency and energy, analyzing diffraction patterns, as well as approximating Planck's constant. The apparatus comes with a power cord, which connects onto the back of the apparatus, which also has an on-off switch. The color and wavelength are written right on the apparatus for easy reference. Once you turn the apparatus on, all the functions are controlled with this top knob. You can have all the LEDs showing, or you can click through and energize only one LED at a time. The activity guide has a color-coded table. Each is in the color noted on the LED array. And what we're going to do now is shine each specific LED light on the color code, and we're going to show you how you get a very different view in the human eye when you have one specific color of light lighting an object. So here's the white LED, and now I'm just going to scroll through each LED one at a time. A very neat introduction into frequency and energy is to lay the LED array parallel to a table and simply connect a solar cell to a multimeter to measure the voltage. Now, there are a lot of variables involved in this. The intensity of each LED is not the same, but it will give them a cool idea as to how the color of light does affect the energy that a solar cell does create. If you hold a diffraction grating up to the LED array, students can see the color spectrum of each individual LED. It's important to note that with LEDs you don't get a very narrow peak, but you get a relatively small band of color. One of the things that you can do is turn each LED on one at a time, and using a diffraction formula you can actually have the students calculate the specific wavelength of each LED. Beyond demonstrations in color and diffraction experiments, you can also have a quantitative experiment to determine Planck's constant. The apparatus comes with a separate power cord that has 2 banana plugs. You use these to connect it to an external power supply, but nothing greater than 5 volts. When you connect a circuit to 2 batteries and a potentiometer, you also want to include a voltmeter and an ammeter measuring milliamps. What you want to do is increase the resistance using the potentiometer until you get a milliamperage of 0. Then record the corresponding voltage. You do this for each individual LED, and then you graph the stopping potential versus the inverse of the wavelength. I won't go through the full derivation here in this video, but using the stopping potential and the slope of the line, you can then approximate Planck's constant. In the experiment that I did, I got about 8% error from the accepted value. The LED array will do more than just grab your students' attention with its brightly colored lights. Through both demonstration and quantitative experiments, students can learn about color perception, diffraction, frequency and energy, as well as approximating Planck's constant. Everything you need to know is in the guided activity guide that comes with the apparatus, and since these are made from LEDs, this will ensure that you will get many years of use out of this for your classroom.